Hi, welcome back to another Teardown Tuesday. This week we're working on this convection fan. We're going to take it apart and see how it works. This is a used part that came back. It has some kind of failure. I think I know what's wrong with it, but when we move the shaft here, you can hear the play in it, but there's also bearing noise. So this probably was very loud when it was in service. But before we tear it apart, let's talk about how it's set up here. So the blower wheel on the end here is pretty typical for moving air. It's called a squirrel cage, and that's on the motor shaft. Then there's this plate that acts as a mount, but it also has insulation in it, so it's a thermal insulator from the oven cavity. Then there's this little piece back here, and we'll be able to see this better once we get the wheel and the plate off, but this is a slinger disc. And what this is designed to do is move air in this back part of the motor. So as it's moving air back there, it's keeping the bearing surface in the motor from getting too hot. So that shaft is trying to transfer that heat back into the motor, and that slinger is helping to control that. So let's start by getting the wheel off. It may come off easy, it may be a bear. There's not a good spot to put a puller on this one. So we'll try it, and we'll see what happens here. Yeah, I might have to heat this up to get this off. Yeah, not a lot of play in the actual hub, so I'm probably going to have to heat this up and give it a tap with a hammer to get it apart. Not too bad. Came apart without too much trouble. So here's our squirrel cage. Now let's get this insulation plate off. So just first screw we tried here seems like it's seized. Not surprising, but there's a tool we can put on this. It's called an impact screwdriver, and we'll probably try one of those next and see if that'll get it loose. So here's an impact screwdriver, and this is a handheld tool. You put a screwdriver bit in the end, you line it up on the screw, and you hit the back with a hammer. And as this system compresses from that force of the hammer, it twists. It'll try and back that screw out. So that's what we'll try and use to get this out. Now a battery powered impact like a modern hand tool might do the trick, but the problem there is you don't have enough force pushing in. So with our impact screwdriver we're using the hammer force to push in at the same time that the screw is being rotated out. So I'll take this over the vise real quick. Let's see if it comes out for us. Even with the impact screwdriver, we were only able to get one screw to back out. The other ones have seized, or the Loctite is too strong, and we've started to damage the heads. So what we're going to do is we're actually going to come in and drill the heads. So we just take the drill bit, run it in the center of the screw, and what we're trying to do is go through the head of the screw down to the actual shaft, and then the head will pop off. So there, we've just drilled through the head, and you can see the head of the screw. So the shaft is still in the motor, but this will at least let us get the insulator off. So now we're going to just grab that and get it off our drill bit and do the next one. So there's the screw head. Alright, so we got one screw out with our impact screwdriver. The other three we had to drill, but we should be able to go a little further now. So taking a look inside, this is the insulation. It's like a white fiber wool insulation. Looks like they had some spacers in here. The back of this plate itself hasn't come loose yet.
Unfortunately, at this point, I ran into some trouble and lost my microphone. So I was still recording the video, but there's no more audio from me doing the actual teardown. What I'll do here is record a voiceover track, because there is some really interesting stuff going on here. So what I'm describing right now is the face there, that insulated face, and trying to get it apart. And I did have to end up hammering that off because those spacers had seized to the screws. And once we look a little closer here, you'll be able to see the screws also had Loctite on them. And that Loctite, combined with whatever galvanic corrosion was going on and the seized spacers, made those screws just impossible to get out. When we look at the back of the motor, we really only had two pieces of data here. We had the voltage, 180 volt AC, and we had the current at 2 amps. The rest of the data plate on here doesn't give us much to work with. It doesn't tell us any kind of phasing or anything, and I think that's mostly because this motor was made for a specific application. When we look at the wiring, we only had 4 wires. We had 3 conductors and a ground. The conductors that we've got tell me it's probably a 3-phase motor, and we could check that if we had our multimeter. What we would do is check the resistance on the windings between like red and black, black and white, and red and white. And if we check those winding resistances and they all 3 matched, that would tell us that it was a 3-phase motor. So it's just an easy way to check. So now we're looking at the top of the motor, the slinger disc, and that slinger disc is moving that air away from the shaft. It's trying to keep that shaft from putting too much heat into the bearing. So now we're going to take that slinger disc off, but to get that off there, probably going to have to destroy it. And as we get further along here, you'll see what happens when I try and get that off. The set screw comes off pretty easily, and we can get the set screw out of there without too much trouble. Yeah, so we're getting the set screw out. That slinger disc is more critical than most people realize, because that end bearing that's closest to the heat source, it can absorb a lot of heat if you don't actively try and keep it cool. And in fact, even with all this effort they went to, it still ended up being a bearing failure in this motor that was probably heat related. So here you can see the fins are all just bending up as I try and pull this off. So the real solution here is going to be to get a chisel in there. And so we get that chisel in, give it a tap, and that pops the collar that's holding that slinger disc on, and we can get that out of the way. Alright, so it pretty much destroyed that, getting it out of there. With that slinger disc out of the way though, now we have access to this ring of fasteners that's holding the 2 pieces of the motor together. So we'll speed through that because it's really not worth watching me just take screws out. So we'll give that a minute here. And it's interesting, at this point in the teardown, the shaft of the motor doesn't turn anymore. It's totally jammed up. In pulling on that shaft, getting the wheels off and the slinger off, the bearing is locked up entirely. I can't rotate it by hand at this point anymore. So we get all the fasteners out, we pop this housing apart, and there's strong magnets in the rotor of this assembly, so it's really hard to actually physically pull apart. It takes a pretty good amount of force. And this is the damage. So looking down inside there, pay attention to all the metal. There's just a ton of metal debris down inside this motor, and you can see it. It's a little shiny. It almost looks like dust, sand all around the casing there, that top half of the motor. And you can see it magnetically attaching itself to the rotor of this motor where the magnets are. You can just see the big chunks of debris all over inside this thing. Lots and lots of debris. Just dust, powder, chunks tons of debris. And it, like I said, it won't turn at this point. Looking down inside here, tons more debris, chunks everywhere, metal everywhere. There's a thermal overload protector that's glued onto the windings. You can see that here pretty clearly. That's a little switch that would open up if it got hot. But you can see down inside there's just tons of debris in here. Dust, garbage, chunks everywhere. This thing is grinding itself up. The longer it ran, the worse it was going to get. And that's all that debris laying on the inside there. More debris. See it pretty clearly here. Pay attention to that back bearing though. That back bearing is still spinning freely. And you can see the grease in that started to burn. It was getting hot, right? But it wasn't the failure point. But you can see the grease around the edges of the seal showing signs of overheating. And bearing failures in particular make these motors run hot. The longer you have a failed bearing, the hotter it's going to get. The bearing will continue to get worse. It'll feed on itself and chew itself up the longer you leave it in place. So now I've pulled this thing apart. I popped it out of the housing. And what we're going to do here is look at the bearing itself. So I put the bearing into a press, put the rotor with the bearing into a press. And I use these two press plates that I'm about to show you to get in there and get that bearing off that shaft. So I made these plates a long time ago, 10-15 years ago. And they're real thin on the edges, so you can slide them into a real narrow gap and press down enough to make more space. And once you make a little more space, you slide back to the thicker part of the plate, and that lets you press the bearings off of those shafts. So I got the bearing off. Next challenge here is going to be to actually get inside the bearing. So this bearing has shields on it, metal dust shields, and those metal dust shields are not easy to pop out of there without getting in and pretty much destroying the bearing at this point. Now the bearing doesn't turn, it's already junk, so what we'll do here is actually physically cut the bearing apart so we can see what happened to it. So here I've taken the bearing and I put it into a grinder and ground through the outer race and then smacked it with a hammer to get it to pop apart. So you can see here the actual balls, the races themselves. This piece is an outer race, and you can see where I cut it, and then this piece is called the inner race. And you can see all the debris and just garbage that's in there now. As it ground up, the grease burned to a real thick paste, and it got chunky with metal. And there are the actual balls of the ball bearing inside of their little cage assembly. And that cage keeps them evenly spaced. But you can see that real dark gray, gritty paste that's all over everything. That's the old grease burned mixed with metal. And as that bearing continued to run, it just chewed itself apart. That metal debris and paste just ground it up into a real fine powder in there. So bearing's junk at this point. So set that off to the side here. Again, you can see the outside of it has a bunch of damage on the outer race. And this is probably where a lot of the metal debris came from. The steel outer surface of this bearing is really marred up. And if you look into the inside of the housing here, into that inner race, that bearing was locked up and spinning inside of the housing. So it's supposed to be a press fit, but it spun after it seized. And that generated a lot more metal debris. A lot of the garbage that's down inside the housing there came from this bearing spinning inside of its pocket. And you can see all that damage from the bearing itself spinning where it wasn't supposed to. And that's how a seized bearing ends up just destroying a motor. And it gets hot, it wears out even faster, it generates metal debris, and it just comes apart. So that's really what killed this one. Now the back bearing there, that is pretty good shape. Back bearing on that spins pretty freely, and it really wasn't bad at all. But that front bearing, the larger bearing, really just failed and generated all this garbage that's down inside the motor now. And that's That's what killed it. All right, so that pretty much wraps up this teardown. I appreciate you putting up with my audio problems this time around, but I thought that failed bearing was really interesting. I figured you might like to see that. So thanks for watching. I'll see you next time.
Hi folks, my name is Jack Kell and I'm a Senior Technical Trainer for SmartCare. The video you've just watched is part of a larger series of technical training videos we make available to our technicians at SmartCare. If you found this interesting and you'd like to see more, please subscribe. I'll be releasing a new component teardown video every Tuesday in 2022. If you're already a SmartCare technician and you have a part that you'd like to see me tear down, please reach out to me internally for shipping instructions. If you're not a SmartCare technician, but you or someone you know would like to learn more about a career as a service technician specializing in commercial restaurant equipment, please check out our open positions at www.smartcaresolutions.com/careers. Thanks for watching.